So our competitors have entered the room. Oh, you can see because they have webcams. Yeah, you all can wave. We'll make sure our webcams look good. They do so far.
Do you want to do the briefing so that, or should I do it?
You should do the briefing, and we'll just we'll hold. Look, oh, so fancy. Alex, stand over here and face that way.
Tell us a few words about this contest.
All right, well, welcome to the finals of the Rapid Fire. I'm going to start by giving a small briefing to the competitors, and then we're going to start. All right, so the finals, again, you will have 4 binary challenges. You will have 30 minutes instead of 20. The finals are sudden death. The first one to solve everything, that stops the competitions. And then we'll rank you based on the number of solves and the last time of the solve. Like the time of the last solve, okay? We will drop source for the first problem after 4 minutes, for the second problem after 8, 12, 16, like we do usually, and I'll give you a sign. All right, so get ready. Put the earmuffs in.
Put the earplugs in before your.
So a few words about the last challenge. Even though we're giving you source, I do not recommend looking at it. It is a lot of code.
It's not a hard challenge.
Just play with it.
All right, so that was the briefing by Alex Herbert from ForAllSecure here at the Cambridge event. So we're just finishing up, making sure everyone's ready before we hit the enter key here and start this event.
You don't have to. You don't have to do that sequentially.
Yes. So again, this is the rapid fire challenge. We have 4 challenges, and we score based on who solves the most the fastest. If one player solves all of the challenges, the game is instantly over. This is a sudden death round. So we're just having our players put on their headphones. All right. Does everyone seem ready? Are you ready?
Yeah!
All right. 3, 2, 1, go. All right, so we're off right away. So we've got several challenges again. So there's 4 right here. So we see Will starting off filing all of these challenges to figure out exactly what he's looking for. Again, they're all just as they were before, x86 binaries. These are actually fairly simple programs. They get progressively more difficult, but the competitors can jump around. We know right away everyone's doing the exact same thing. Everyone's opening up the program in IDA and looking around, and wow, the timing is eerily similar between the competitors. They all seem to be doing almost exactly the same thing. So note that we see Witch Corn over in the corner. He's trying to send a bunch of A's. This is actually a reversing challenge, not an exploitation challenge. Again, hopefully he doesn't hear me. It's hard to know because he's sitting very close to me. Yes, this is actually a reversing challenge. So we have 2 types of challenges. We have reversing and we have exploitation. And they have to figure out which one is which. So it looks like Julian over here in the corner has a decent idea. Not quite. So this challenge, so all these challenges as a rapid fire events are based around fire. So this one is called Fire Truck. It asks for the best type of truck. We see that Will has a good idea over here, but he's forgetting about endianness. So he's actually getting the endianness incorrect. So, it looks like we actually got a first solve already. So Rahul has solved Fire Truck just 1 minute and 4 seconds into the game. So Rahul is currently in first place. And now he's on to the next challenge. We still have Will here, looks incredibly close. So the answer, for those of you playing along at home, it's actually ice cream. We'll see if he figures out ice cream. Yes, that's the best type of truck. All right. So we have 2 solves, and 3. We've got 3. So it's moving along. So these are the top 4 competitors from the previous events. So it's a very competitive game right now. So now they're onto the Charmeleon program. So this is this is actually more of a reverse engineering challenge than an exploitation. It's asking the players to enter some bytes. You can see the bytes here in IDA right there. It's a little bit tricky. Again, these are non-printable characters. This gives some people sometimes a little bit of trouble. Inputting non-printable characters can be a little tough. So we see Rahul here is looking closely to see exactly what the program is doing. So he's analyzing an IDA. Again, a very common choice among these competitors for how to do things quickly. Julian down here, he's got a decent idea. He's entering them. Oh, and here he's flipping the endiness. Now he wrote out the string first, copied directly from IDA. Now he's kind of manually doing the endiness. He forgot to delete that 2. That might not matter. Oh, that might matter. Oh, and it looks like he has the 0 in front of the F still. That's actually left over from IDA. That's not actually part of the number, so we'll see if he figures that out. Oh, it looks like Will has actually solved Chameleon already. That was relatively fast. Again, this was a not too difficult a challenge. Is mostly a reverse engineering challenge, and now he's on to Firebird, which is the first actual exploitation challenge. So again, this is actually a not too difficult challenge. And we have Julian here, who's also just finished the Charmeleon task. So again, these competitors are going very quickly. So you've got three solves on Firetruck and 2 on Charmeleon. So we're moving quickly along here. So it looks like Will's got a seg fault. So the way this program works, it actually asks you precisely what value you would like to write and where you would like to write it to. So we see that that Julian and Will are working on this right now. It looks like Rahul is still finishing up Charmeleon. He's got a decent idea, but it looks like he doesn't quite have the ASCII bits right. So he's entering printable characters. The result has to be non-printable. So it's comparing your input directly to a number. But if you enter the non-printable characters described by that and you handle the endiness properly, it should just work. So Witchcorn down here in the corner, he's still working on Firetruck. He's very close. And you can see he has the right start of this right here, but he doesn't quite have it. It looks like he'll probably get it quite soon though. All right. So looking back at Will, so he's on Firebird. He's got a rough idea of how this program works. So it turns out there's actually a very nice function pointer located in this program, and so it gives you a write, what, where primitive. And if you locate the correct function pointer, it's actually quite easy. Just rewriting the function pointer with the address of your execute me function will do exactly what you need it to. And so just to remind everyone, this is we're at the Cambridge to Cambridge event at MIT CSAIL in Cambridge, Massachusetts. So we have players from the University of Cambridge from the United Kingdom, as well as Cambridge here in Massachusetts, where we're broadcasting from. So they've been playing in events for the past 2 days, or since yesterday rather. And this is the final round of the rapid fire event. So it feels like it's been a while. It's actually only been just a few minutes into the competition. It's only been 5 minutes. We've got several solves, but the winner is still kind of up for grabs at this point. There are 4 challenges total, and only 2 have been solved, and there's 24 minutes to go. Again, this is a sudden death round, so this is a little bit different from what we've had before. So it looks like we've our challenges have a decent idea of what to write. So here we have Julian, where he's writing the address of the execute me function, but he's writing it to this address 1010101. Of course, that's not a valid address in this binary, so it's going to segfault. But it looks like he has a decent idea of what he needs to do and just needs to find the correct address to write. And Will over here, he's doing something similar. So it looks like rather than going for the function pointer in the program, it looks like he's actually using a stack address. So it might be possible if he gets this in the correct stack frame to overwrite his return address with the address of the execute me function. It's unclear whether or not he's writing it in the correct stack frame, or if some other issues might occur. For example, stack randomization might also be messing him up. So checking back at Witchcorn here, he's very close. We can see he got the first few letters right. And there's still a little bit of endianness issues going on there. So if you look, it looks like he has the first 4 bytes correct. So he's got the first double word. But the second one, he's got the endianness swapped on. Given how close he is, I'm sure he'll figure that out very quickly. You can see he has almost got ice cream. There, looks like he figured it out. I figured it out, and got it. All right, nice. So we've got all competitors have solved Fire Truck. We've got 2 solves on Charmeleon. And again, still kind of anyone's game at this point. We've got 22 minutes left on the clock, and we'll see how things go. So it looks like Will here is going to start taking a brute force approach. So he has a decent idea of what to do. But again, he's trying to go for a stack address, which is a little bit of a tricky way of doing this due to randomization. So it looks like his solution to that is going to be try several different values in quick succession and see if any of those work. Also, it looks like it's been enough time here for us to have dropped source. So I think the first challenge, or maybe the second one, has both the first and second challenge have the source released for them. So we'll see if any competitors that are stuck on challenge number 2 start using this. So again, it seems like this write what where is giving people a little bit of pause. There's this very kindly named printer function pointer that you can identify in Will's IDA. You can see it kind of near the bottom of the screen there. So this is exactly what he needs to overwrite. But again, it looks like the challengers are not finding quite the right thing to overwrite here. So you see Julian again. He's looks like he might also be going for a stack address. I see some F's in there. We'll see what he ends up going with. Yeah, it looks like he's also going for a stack address here, rather than, again, the function pointer, which is kindly included in this binary, but hasn't yet been noticed. We'll see how that pans out. So Witchicorn here, actually very close. He's almost already got the this next challenge. So again, this was the Charmeleon challenge where you have to enter these non-printable characters. It looks like he's just about there. So he actually should be solving that pretty close, which will bring him up to the same number of solves as Will and Julian. But if we look, it looks like Rahul, who's the first to solve Fire Truck, is still working on the next challenge. Actually, it looks like he's skipped over challenge number 2. Again, competitors can complete these challenges in any order they feel like. The challenges are all weighted equally, so their job is to basically to solve as many as they can. We believe our chosen order has been a little bit different from what they've done. So we kind of put them in the easiest to hardest order, but they can skip around if they feel like they're getting stuck. So it looks like Rahul here, for example, is not including the addresses as the non-printable character. He's not using raw bytes. Instead, he's actually using the ASCII. And that's giving him some issues. He can see, you can tell he's looking at these numbers and saying, why aren't they matching up? He'll probably figure that out pretty soon. And over here, back up at Will's screen, we can see again his brute force is going along. He's got basically brute forcing the least significant byte of his stack address here, but it's not quite clear if this is going to pan out for him. This stack address isn't necessarily going to be in the correct stack frame, and it might actually be the return address. And also, looking at the last 2 significant bytes of those addresses he's printing out, it looks like he's printing out printable characters. Those are 2 numbers. And it looks like he might not quite be doing what he expects to be doing, so that's unfortunate. So it looks like he's taking a strategy we've seen before. While he has a brute force going, he started on the next challenge. This is Snake. Oh, looks like we just got something solved. Yeah, Witchicorn just got Charmeleon. So as we saw, he was actually quite close to that and solved it very quickly after taking a little bit with Fire Truck. But now he's just at the same place as Will and Julian are. So Will, we see, is entering a lot of A's. And let's see, Rahul here is still looking at this write what where, and again having a bit of trouble with the fact that he has to enter non-printable characters. So you have to enter the raw bytes for the addresses, and here he is inserting ASCII characters. And let's see. So here we have Julian. We got Will just got Firebird, so he looks like his stack brute forcing did pay off for him. So that's great. So his brute force solution paid off. So now he's on to the last challenge. This is a game of Snake. So he's got a decent idea what he's doing. So it's common how you know, normal play of Snake, you create a little snake and you move him around on the screen. This is a little bit different from other things we've been doing, however. So we have 17 minutes left on the clock, so we'll see if that's enough time for them to get it. Again, this is sudden death, so whoever is the first to solve all 4 challenges will be declared the victor. So Julian down here, it looks like he's also moving on from, he's kind of skipping over Firebird. It looks like he's having some trouble with that right what where, and maybe he's going to start looking at Snake instead. This is a reasonable strategy to take, but we'll see if it pays off. So we have dropped the source code for Charmeleon. Again, the way that this works, we periodically release the source code for these challenges as time goes on. So there's 16 minutes left from our 30-minute game. So we've released the challenges for 3 challenges. So that's up to Charmeleon, which is the challenge that he's currently looking at. So Will here is already sending some bytes into Snake, and it's causing some crashes, but it doesn't look like he's quite got figured out what to do. So just from looking at the game, you can, those following along at home might be able to tell exactly how this is set up. So you can enter the name of your snake and then move him around on the screen. And of course, if you move him off the screen to a certain location, you can actually overflow a buffer. Part of the issue here is making sure you don't overwrite something that just causes the program to exit immediately. So you'll note, for example, that you can press Q to quit, and if you exit cleanly and try to return out of the function by doing Q rather than moving around until it segfaults, that might be a little bit better. So it looks like Julian here has some idea of what he's doing. He's grabbing the location of his execute me function, and it looks like he's also still, oh no, actually it looks like he's finally found that function pointer. That's actually probably going to solve it, so we'll watch if he solves it right now. Yeah, there he goes. Quick solve. Just a little smirk, not much reaction showing there, but that's all right. So it looks like now we've got him, and so we've got Will and Julian both solving Firebirds. They've solved 3 challenges. So the one left for them is going to be Snake. So we'll watch them both playing Snake. Meanwhile, we have Witchicorn, who solved the first 2 challenges and also on Firebird. And we have Rahul currently a little bit behind, still trying to figure out how to send the correct bytes to Charmeleon. So again, for those just tuning in, so the way this competition works, we have four binary challenges. They're all compiled x86 32-bit programs. So competitors have to reverse engineer the challenges. Their goal is to find an execute me function and jump to it. So redirect control flow to that function. The first 2 challenges have basically been reverse engineering challenges. So Charmeleon and Firetruck, and the next 2, Firebird and Snake, are actually more of a traditional exploitation challenge. So looking at Witchicorn here, it looks like he's actually about to get this challenge as well. He's found that function pointer right away. Didn't mess around with the stack as we've seen before, and there he goes, solving that challenge as well. So Witchicorn is closely trailing behind Will and Julian. So we've got 3 solves on Firebird. So this means that with about 13 minutes left in the game, whoever gets Snake will be the winner. So we see, again, this is a fairly complicated program. Opening up an IDA is actually kind of a mess because this is implementing, again, actually a version of the Snake game. And so it's actually quite a bit of code to look at. And so we see, rather than trying to mess around and reverse engineer this program, they're just kind of playing around with it, which is, again, a fairly good technique. So it looks like we can see what they're trying to do. They're moving their little snake around and trying to understand how this affects things. So checking dmessage to understand. So it looks like Rahul got Charmeleon, so he's a little bit behind here. But he figured it out, so now he's on to the exploitable challenges. So now he's on Firebird, which is that write what where. So he's just 1 challenge behind the other players right now. So we've got Right now we have Fire Truck, Charmeleon solved by all players, and Firebird solved by all but Rahul. But again, this is still a close game. We've got 12 minutes left on the clock. This is the final round, so all of these players have been playing, practicing these sorts of challenges since yesterday, and they qualified for this final round because they've bested their peers here from both of the Cambridges. So again, for those who are familiar, this is the Cambridge to Cambridge event. So all of the students here are from either the University of Cambridge in Cambridge, from the United Kingdom, or from MIT here in Cambridge, Massachusetts, where we are broadcasting live. So we see a few players again playing around with Snake, trying to understand it. We have released the source code for it now since time is running out. So source code is released for all the challenges, but again, it's a fairly complicated program. And really the insight has to come from playing around with it to understand how it's working rather than actually reverse engineering it, because that's quite a difficult challenge. So again, unlike normal, in the past, a lot of these competitors have had challenges where they simply cause a seg fault and then change addresses or alignment around a tiny bit in order to cause control flow deviation. But here it's actually a little bit different. Although it actually looks like Julian here might be fairly close. Oh, there he goes. He's got it. So the game is over. Julian has gotten first place, followed by Will, followed by Witchicorn, followed by Rahul. So everyone did a great job here, and that's it. I don't know what else to say. So congratulations to Julian. Congratulations to all our competitors. Again, they all did a great showing here. Yeah, so this concludes the rapid fire challenges from our Cambridge to Cambridge event. So if you stay tuned, we'll broadcast probably the award ceremony in a little bit more. Yeah. There's a little bit of an interview here describing how he solved it. Yeah, so if you notice, Julian actually, rather than moving his snake up off the screen, he solved it by moving his snake down to the bottom of the screen. So this changes which buffer he's overwriting actually, and ended up allowing him to exit a little bit sooner. So he was just able to beat out Will, who was hot on his tails, as well as Witchicorn, who was not far behind either. And so yeah, so this concludes the rapid fire event. So we'll just have a bit of a Q&A period among us personally. For those of you tuning in, you can ask questions on Twitch or something. And the award ceremony will be a little bit later. Yeah, so hope you enjoyed it. You were close, man. So if you do Q and you quit, it'll return from the function. So the issue is, so if you did what you were doing, you were going up until it crashes. If you go up a bunch and before it crashes you quit, it'll return. Yeah. Or you can go down.
Go down walks?
Yeah, apparently. I know. I usually when I solved it I went up and quit. But yeah, it's close. Oh wait, I should stop streaming. Goodbye, YouTube or Twitch people. Goodbye. We'll try to post these online later, etc., etc. We are recording them, I think, so that should be doable. Well, we're recording them locally, and Twitch is supposed to archive for some short period of time.
Both of those things.
Both of those things hopefully will work. Anyway, thank you for watching. Check back later for our full award ceremony with all of the events.